Hello dear students. From this video onwards, we will learn Push Down Automata. As you know, automata is nothing but a machine, or rather the model created for a machine. Now the push down automata can be best explained using a block diagram as shown here. What we have in push down automata is that we are having an infinite tape as shown over here, infinite tape on which some input string is coded. For instance, the input over here is double A followed by double B. What rest remains on this input string, at the end of the input string, we have nothing. By nothing, we mean epsilon. We have infinite array of epsilons over here. But this portion is the input string. Okay. Then as we have a tape, we are supposed to read the symbols from the tape. So what is given is a head is given, a read head. Now clearly observe this head is a read head. It's not read write head. So using this device called head, we can only read a symbol from the input tape, but we cannot write anything on this tape. Also, what is given is in PDA, a state control is given. Now PDA is after all a machine like DFA. You remember DFA had states like Q0, Q1, Q2, and there was an initial state, then there were set of final states, and there were transition between the states. Just like that, in PDA also, push down automata, we have states, initial state, final state, and transition. So how that states are supposed to be controlled, rather which is the initial state and when will the transition occur, all this is controlled by state control. Now one very important thing that we have in push down automata is push down store. Now this is a kind of memory. This is a memory given where you can store some symbols or you can remove some symbols. This is a last in first out memory given, or called as a stack. Now you all know that stack has two main operations, push and pop. That's why this memory is also known as push down store. Store means storage, and push down store is nothing but a stack. So this machine got the name push down automata. This name push down automata is given because PDA has a storage device or storage location which is push down store or a stack. So what does a PDA contain? Infinite tape on which input string is coded. It has a read head which can only read symbol from the tape, but it can't write a symbol. Also it has state control like Q0, Q1, Q2 and so on. Some states are there, and it has a storage which is called a stack or push down store. Now let's see definition of PDA. And as usual, the things happen when we read this mathematical definition, we hardly come to know what PDA is all about. But fact is fact, the definition is more important. And once we read out this definition, then we can understand what's given in this definition by learning a few things by help of pictures. Okay, let's concentrate on the definition. The definition says that PDA is 1, 2, 3, 4, 5, 6, 7, 7 tuple, because PDA is made up of 7 things. The first thing is Q, which is nothing but finite set of states, like PDA will have states like Q0, Q1, Q2 and so on, just as DFA or NFA had. Then it has set of input symbols, sigma. Here, sigma is finite set of input symbols. Basically, these are the symbols which form the input string. For instance, in the diagram shown above, we see that the input string on the tape, as you see, is double A double B. That means the input is made up of A comma B. So sigma in this example is A comma B, set of input symbols. Okay. What next comes in PDA is delta. Now this delta was a transition function. You recall in DFA also we had to define this transition function saying that whenever a state reads some input, does it change the state or does it remain in the same state? So transition here means whether the machine will transit from one state to the other state, and if it does, then what are the rules for doing that? So that's the transition function delta. Now this q cross sigma cross tau, this symbol I read it as tau, I don't know, it might be read as something else also, but who cares? This is some Greek symbol. But then q cross sigma cross tau maps to, or rather results in, q cross tau star, is the definition of delta. Don't worry, we will be learning this definition in big detail because you know it very well. The working of PDA is all about this delta. Other things are quite understood very easily, but to understand the working of PDA, one must understand transition function. So we will be learning this in big detail. Next comes the Greek symbol. I don't know what this is read as, but I read it as tau. Please excuse me if I am wrong. But then this symbol, is finite set of stack symbols, you see. Now you all have seen the block diagram and you see that we have been given a stack and we can push or pop some values or some symbols on the stack. Let's say that the stack contains some symbols, some arbitrary symbols like Z0, X, Y, and so on. Then this Z0, X, Y are stack symbols. Note that input symbols are A comma B, but stack symbols are Z0, X, Y. That means the input symbols and the stack symbols can be different. So tau is a set, basically, is a set of stack symbols. It is those symbols that you are going to push or pop from the stack. Next here comes Z0. Now observe, Z0 here is the initial stack symbol. What happens in PDA, the PDA that we are learning in this series, is that whenever PDA starts its execution, of course PDA will start its execution from initial state. At that point of time, the stack is never empty. Listen very carefully. The stack initially, when the PDA starts, is never empty. Some symbol, one particular symbol on the stack exists in the beginning of the PDA. Let's call that particular symbol as Z0. Just some name I have given. So Z0 is the initial stack symbol. Well, in this type of PDA that we are learning, we will see to it always that stack is never empty. So initially also, even before PDA starts its execution, this Z0, a special symbol, will be there on the stack. What we have next is S, which is initial state of PDA. Of course, PDA has Q0, Q1, Q2 states, and one of the states will be initial states. And we have set of final states just as DFA had. DFA had some states which were double circled. Even PDA will have set of final states. Clearly the final state is subset of states because final states are going to be from one of these states, isn't it? That's the definition of PDA. Well, I'm sure just as it happened to me when I was learning this for the first time, when I read the definition of PDA, nothing was clear except I knew that some states are there, input symbols are there, some initial stack symbol is there. But what was very unclear is this delta function, transition function, and it looks so complex where q cross sigma cross tau maps to q cross tau star was very difficult to be understood. So when we return in our second video on PDA, we will learn working of PDA. And in the working of PDA, we will draw some pictures and we will try to understand what is this delta function. Trust me, learning delta function is it. You will understand what PDA does only if you know what delta function does very properly. So see you in the next video. Thank you very much.